All right, well, welcome everybody, and thanks for joining us here with our virtual astronomy day. Want to take you through a little video astronomy journey through the universe, and I want to sort of focus on the scale and the size of the universe, and just trying to come to grips with how big the universe is. Sometimes the numbers and distances we deal with are just sort of unbelievable. So I'll just start off here. This is my observatory. I'm just south of Ottawa. Some people in Eastern Ontario might recognize the bridge here. It runs from Prescott or Johnstown over to Ogdensburg, New York, just a couple kilometers away. And this is it's a soft cover observatory. Works really well. Stays out 12 months of the year, and had it for about 5 years now. Works really well. And this is a Wi-Fi antenna, so I can connect with the Wi-Fi in the nearby house to broadcast images. And yeah, this is getting ready one night, and unfortunately the sky tonight is nothing like this. It's clouded over, but all of the images I'm going to show you in the presentation are all screen captures that I've taken with my equipment. They're not processed, not stacked. They're just what we would have seen live tonight. So you know what, we're going to see more images than we could have otherwise, so it'll work out okay. This is inside the observatory. This is my main scope here. It's an 11-inch Schmidt Cassegrain. It's a Celestron, called a CPC-11, and it's on an Altaz mount. If you've been watching today, you've found out that there's equatorial mounts that track really well. They're aligned with the polar axis of the Earth, and then there's these Altaz mounts that sort of rotate in this direction, and the scope can go up and down, so they sort of move in two axes. But it works really well for me. I get really good tracking for longer exposures. The light in these, it comes in the front of the scope here. There's a concave mirror at the back. Light gets bounced back to the front. There's a little secondary mirror mounted here. There's a corrector lens at the front, and the secondary mirror is mounted in the middle of that. And then the light is bounced back once again out the back of the scope. And you can see here I've got a video camera, a Malincam camera. Jim showed some of those earlier. And this is a little refractor I've got mounted on top of the main scope here, and it gives me wider fields of view just for different objects. If I want a wide field of view, the big scope, it's a longer focal length. It's got a narrower field, so yeah, they both work good for their own applications. And you might have seen the guys today doing solar observing. This is a solar scope that I have, and sometimes I'll switch it out and put it on top of the big scope, and we'll get some solar images that I'll show you also. This is just the scope outside the observatory. That's just looking in the open end of the scope, and you can see that mirror in the back where it bounces the light up to the secondary mirror. The secondary mirror is on the back side of this little round portion here. And this is in the observatory at night. We've got the laptop here. We control the video camera from that, and second monitor. Most times I'm out, I'll broadcast on nightskiesnetwork.ca. Anybody can come on there. It's free to come on anytime and join in and see what we're looking at. It's a lot of fun. An iPad mounted here and use that with a program just to see what's in the sky and where things are. So just to start out, we're dealing with huge numbers in astronomy. So just to get our heads around some of these numbers, 1 million sheets of paper would be about the height of a 30-story building, but 1 billion sheets of paper would be 10 times higher than Mount Everest. So hard to believe. In time, 1 million seconds is almost 12 days, but 1 billion seconds is almost 32 years. So we deal with a lot of these huge numbers. So we'll get started. I thought I'd just start off in the solar system. We'll start off at the Earth, and our next door neighbor, there's the moon, 384,000 kilometers away. It's just right on our doorstep in terms of the universe, but it's actually just as far as humans have made it directly. 12 men have walked on the moon, that's all. And not since the 70s. But that's our moon. Takes light 1.3 seconds to reach us from the moon. Moving on to the sun, some images from my solar scope. That's some prominences. The guys were showing some prominences earlier today on the surface of the sun. Our sun, 150 million kilometers away, 109 times the diameter of the Earth, and takes light 8 minutes, 19 seconds to reach us. And this is just some detail on the surface of the sun here. We can see these light and dark areas, which are temperature differences, some activity there where we've got changes happening on the surface. hard to believe that these numbers again, every second of every day, 564 million tons of hydrogen every second gets fused into helium, and that's what powers the the nuclear core of the sun and produces all the energy. Just incredible incredible numbers there. And by that cosmic coincidence, it just happens to be 400 times bigger than the moon, but also 400 times farther away. So those solar eclipses just work perfect. The moon just covers the sun. We've got some sunspots here showing up. And then Jim actually this morning showed a prominence similar to this, so sort of a loop prominence. And the day I watched this one, as Jim was saying earlier, over the course of a few hours, you can see it change. So that's not a real common thing with astronomical observing, where you can see changes like that within a few hours. So I'm going to show a few non-astronomical images here for a few minutes. Some of you might be familiar with Carl Sagan, and he wrote the best-selling book Cosmos way back, and they made the TV series from it. And well, he taught at Cornell University in Ithaca, New York, in upstate New York. And this is in Ithaca, and they, in 1997, they created the Sagan Planet Walk in memory of Carl Sagan. And it's just, this really struck me. This was a few years ago that we were there, and this is yours truly. And this is the size of the sun. So the scale of the Sagan Planet Walk is 1 to 5 billion. So the sun is 5 billion times wider than this. And what you do, this is Ithaca Commons. They've closed a couple of the main streets in the downtown core as sort of pedestrian walks. So you start back this block behind me there and walk about 10 meters, and you get to the Mercury obelisk here. And they have the same size disk of the sun, and they have a little hole punched in it to show the size of the planet. You walk another 8 meters and you come to Venus there, and really it's really hard to see the hole. It's so small in there. Another 8 meters past Venus, you get to the Earth, and I've got a close-up. So there's the little punch out for the Earth. And you start to realize when you're walking, you think, the solar system is just so much empty space. These little holes are so tiny. And you walk another 16 meters and you get to Mars, and you can barely see the hole for Mars. It's even smaller than the Earth. And I put this in. I tried to match what Mars looks like in a backyard telescope, just the red planet, just sort of a reddish disk there. This is sort of a neat picture. So you've got your sun obelisk here. You've got the 4 markers, Mercury, Venus, Earth, Mars, and you're just thinking how small those little holes are. And look at all that empty space, and you're starting to think, wow, the universe is it's a lot of empty space. So then we sort of turned the corner, and we had to walk another 100 meters up the block, and we came to the Jupiter one. It's on the corner of a church here. And of course, you can see Jupiter's a little larger. And then another 120 meters or so, and we came along to Saturn, and we were sort of pressed for time that day. So we didn't make the full walk. We didn't get all the way to Pluto. Now, when this was done, Pluto was still officially a planet. So it's 1.2 kilometers to get to Pluto. And I just put a couple images in. That's, again, trying to match what these look like in a backyard telescope. That's what Jupiter looks like in a small scope. Just, you can see the cloud bands there. And Saturn, at our astronomy days in Ottawa, when we have the live astronomy days, we get such the reactions of Saturn's visible when people see it for the first time. It's unbelievable what it looks like in a small telescope. And that's pretty much it. So the planet walk is neat, but what really amazed me was when I found out that in 2012, decided, you know what, we're going to expand the planet walk. We want to add a marker for the nearest star to the sun, and they decided to do that. And you might think, well, I wonder where it's going to be. Maybe in Pennsylvania somewhere, or maybe the Midwest, or maybe across the U.S. Would you believe the marker for Alpha Centauri? It's a triple star system. It's the closest star system to the sun. The marker is at Hilo at the University of Hawaii, on the big island of Hawaii, over 7,000 kilometers away. So at that scale, that's how far away the closest star is to us. So when we get to distances like that, we have to move to a different measuring stick. So we go to light years and the speed of light. So light covers 300,000 kilometers a second. So in a year, light will travel 9,461 billion kilometers. So think about our billion seconds as 32 years and billion sheets of paper. as 10 Mount Everest. The numbers are just staggering. And Alpha Centauri is actually 4.24 light years distant. So just think of all the empty space. That's the closest star to us. So we'll move on to our Milky Way. So as Simon was talking about, our Milky Way, you know, this is M33, which is one of the closest galaxies to us. It's a spiral. And this is M101, Simon also mentioned. It's about 10 times farther away. It's sort of got a looser spiral structure. And Simon also, he mentioned the M numbers, Messier, after Charles Messier, who became famous for his catalog of objects that bothered him when he was looking for comets. But anyway, our sun's about halfway from the center of the galaxy. Of course, we can't see the Milky Way because we're in it. But if this was the Milky Way, our sun's about halfway from the center out to the edge. And it's just a little speck here. Imagine our sun and Alpha Centauri there. So let's do another scale adjustment. Let's make the Earth's orbit about the width of a dime. And if it was a width of a dime, the Milky Way's diameter would be the diameter of the planet Earth. So that gives you an idea just how huge the distances involved would be. And at that scale, the stars in the sun's vicinity would be about a mile apart. So that just gives you an idea just how huge the Milky Way is and how much empty space there is. So this is Simon also an NGC 81. It's a nice edge on spiral galaxy. Our Milky Way would probably look similar from the edge. If you took two compact disks, held them together, you get about the right dimensions, like say around 120 to 150,000 light years diameter, only about 10 to 20 light years thick. And you can imagine, as Simon mentioned too, whenever we're looking out in these directions away from the plane of the galaxy, we're not looking through nearly as many stars, so there's not as many stars in those parts of the sky. In the summer, we're looking along the plane of the galaxy. When we look along the plane in this direction, that's where we see that band of bright light across the sky, the Milky Way. And even in the winter, not as much, because when we look at in the winter, we're looking towards the outside of the galaxy. So we're not looking through quite as much of the galaxy, but still we can see that band of Milky Way going across the sky. We're going to look at deep sky objects within our little corner of the Milky Way galaxy. So all these are within about 8,000 light years. And I tried to make the Orion Nebula. A lot of you might know the constellation Orion with the 3 belt stars. And this Orion Nebula is the hazy patch just below Orion's belt. And naked eye, it's the brightest nebula in the skies for us. I tried to make this look like what it sort of looks like in a small telescope. Of course, you don't see color in the scope. Our eyes aren't very good at seeing color, but looks sort of similar to that. And this is a stellar nursery where new stars are being born. The gas in these nebulas is coming together and forming new stars. So after these stars that are born, after several thousand years, million years, they start to move apart from each other. The gas is gone from the nebula, and this is the Pleiades, or the 7 sisters, visible in the winter, and it's a very famous star cluster. Some people mistakenly think it's the little dip, very, very small though. And this is M6, also the butterfly cluster, and it's also quite close to us in our neighborhood in the Milky Way galaxy. So with stellar evolution, yeah, some of the regular sized stars, they will go on to form planetary nebulas, as Simon was mentioning. Some of the really large stars, they'll go to supernovas where they actually explode. And interestingly enough, this is a pair of galaxies that are very distant. They're about 80 million light years away. And on March 31st of this year, a supernova was discovered in this one, in the one galaxy. And this is the supernova. So if you would have looked at this in middle of March, you wouldn't have seen that star-like object. And you can see all of a sudden it becomes a supernova, and it rivals the core of the galaxy for brightness. So it'll be interesting. That was an image I just took a couple weeks ago. It'll be interesting to monitor that over the next little while and see how bright it stays over the next little bit. This is the Crab Nebula, as Simon mentioned. In the year 1054 AD, this supernova was recorded by the Chinese and other cultures. And yeah, this is what we've got, the Crab Nebula, the supernova remnant that's left from it. It's looking out away from the center of the Milky Way into the next arm out from us in the Milky Way galaxy. What can I say? It's expanding at 1,800 kilometers a second. So almost 2,000 kilometers every second of every day this is expanding. But over our lifetimes, it won't really change in appearance because it's so huge and the distances are so large. It's about 6,200 light years away. About 13 by 11 light years, that's the dimensions of it, 13 light years by 11. So these are just huge objects. Yeah, they had recorded it was 4 times brighter than Venus in the sky when that supernova occurred. This is also looking away from us out towards the edge of the Milky Way. This is a really nice cluster called the Perseus double cluster. It's just visible to the naked eye as 2 fuzzy patches, but very, very nice object. Now, when we start to look the other way in the summer towards the center of the Milky Way, we get some really dense star clouds. This is a wide angle screen capture here looking towards the center of our Milky Way. And this is 2 nebulas, M8, the Lagoon Nebula, and M20, the Trifid Nebula. These were taken with my small scope to get that wider field of view. So this is the Lagoon Nebula, M8, and it's had a star cluster emerge from it here of some young stars. Very large object, covers an area about the same as 3 full moons in the sky. And if you had a really dark sight and really good conditions, sometimes you can see a bit of it with the naked eye. The Trifid Nebula, M20, it's one of the youngest emission nebulas that we know of. It's only about 300,000 years old. They've done detailed studies on this, and they've shown that there are about 30 what they call embryonic stars just starting to form in it, and about 120 newborn stars in this nebula. It's very nice nebula. One of the ones you see images of a lot, just because it has the red emission nebula here, it has the blue reflection nebula, and then it has the dark nebular structure here blocking some of the red behind it. Interesting little thing on the original Star Trek series, you saw images of the Trifid Nebula made it onto the set quite frequently. Moving a little farther along that arm next to us towards the center of the Milky Way is the Swan Nebula, or also called the Lobster Nebula in the southern hemisphere. It's one of the brightest nebulas in the sky. About 35 newborn stars are embedded in the nebulosity in this nebula. And then Simon was showing us the Eagle Nebula, M16. It's already produced a cluster of young stars that has the really distinctive eagle-shaped dark structures here. I'm not sure if anybody has heard this, but I had heard that somehow they have done measurements and there may have been a nova or a supernova incident near this, and that the pillars of creation may not be there right now, but we don't know yet because the light hasn't reached us. So I've got to do a little more reading about that. That's something about astronomy. We're looking back in time. You know, these things are several thousand light years away. So by the time those photons reach us, we're seeing the object as it was thousands of years ago. Some other objects in our corner of the Milky Way. I think Simon actually showed an image of this too, the Crescent Nebula here. It's actually more of an oval shape. I just picked up the brightest portion here. It's also a supernova remnant. And Simon also, I believe, image of the bubble here. That's a planetary nebula. Whenever you get a star reaches near the end of its life and it turns into a red giant, it sheds those outer shells of gas and they start to produce this sphere of expanding gas. You're left with a really dense, powerful star in the center. So that was interesting. William Herschel, he was a famous astronomer in England who discovered a lot of objects, and he had become pretty famous for discovering the planet Uranus. I believe it was 1681, and a few years later, Messier had already discovered several of the objects in that century also, but when he was looking at the Dumbbell Nebula, he said, you know, it sort of looked like a planet in some of their primitive scopes, and he coined the term planetary nebula, and that term stuck, and they're still known as planetary nebulas, even though they have nothing to do with planets. This is the Cocoon Nebula here. It's a nice nebula. It's quite faint, but it has a lot of dark nebulosity in the center. There's some blue reflection nebula that I barely picked up there. And this is one in the northern sky. it's sort of interesting. They call it the Little Lagoon Nebula because some people think it looks like M8, the Lagoon Nebula. So moving on, here's the dumbbell that you just had a look at in the last presentation. Also, one of the finest planetary nebulas, probably the finest one in the skies. Very colorful and yeah, just a very nice object to image. Just sort of some different colors in those two different views of it. And also the Ring Nebula there, which isn't too far away from the bubble in the sky. This is in the near Vega in the constellation Lyra in the summer skies. And it's also a planetary nebula. I just showed several star clusters here. So these are all open star clusters, sort of, again, just in our neighborhood of the Milky Way galaxy. M36, 37, 38 here, they're all in the constellation Auriga, one of the winter constellations. They range, they're anywhere from 15 to 25 light years across, those clusters, and around, you know, several hundred million light years old. And yeah, there's all different clusters, different densities and different appearances of them. This is one of my favorites here. This is called Caroline's Rose, and it's a cluster. It was actually discovered by Caroline Herschel. So William Herschel, I mentioned earlier, she was his sister, and she would jokingly say that she was his servant, but she actually became a pretty renowned astronomer in her own right, and she discovered quite a few objects. And this was one of the objects that she discovered. This one's, out of all these objects we've been looking at in our Milky Way, this is probably pretty much the most distant. It's about 8,000 light years away. You can see a parallelogram here in this part, and that's the same parallelogram on this side. So this is just sort of a zoomed in area of the center of that cluster. The one interesting thing about this open cluster is it's very old. It's about 1.6 billion years old. So it's a good segue into our next set of objects, the globular clusters, which are even a lot older than that. But as Simon mentioned, the globular clusters, they're found in the halo of the Milky Way. They're like little miniature galaxies, spherical, tightly bound together, very dense, and there's about 150 to 160 identified around the Milky Way. There could be more that we don't know about. Most larger galaxies that we can observe seem to have globular clusters. Some of them have a lot, and it's thought that they are formed when the Milky Way formed, they are formed in the process of the formation of the parent galaxy. Some of them can have up to 1 million stars. And as Simon mentioned too, they're very, the stars can be very densely packed. So we talked about that scale, the scale of our Earth's orbit being a dime, and the stars being about a mile apart at that scale. Well, if we were in a globular cluster, yeah, they'd be a lot closer together. We wouldn't have to hike all the way to Hawaii to get to the nearest one in the Sagan Planet Walk. We might only have to go 50 miles to get to one there. But yeah, lots of interesting globular clusters here. M4 is one of the closest ones to us, only about 7,000 light years. M12 is an interesting one. It's actually, I think, passed quite close to the Milky Way, and they figure it's lost a lot of its stars to gravity from the Milky Way galaxy. M13, the Hercules cluster, probably the most beautiful globular cluster in the northern skies, the most observed, and lots of nice ones. You can see they're all got their own characteristics. M22 is a very bright globular, and it was one of the first ones back in the days of Messier and Herschel. They saw all these fuzzy objects and they couldn't tell if they were nebulas or galaxies or clusters, and M22 was quite bright, and they were able to definitively identify stars in it and say, hey, that's a star cluster. So it was one of the first globulars to be actually identified as a star cluster. M69 and 70, both small ones, and Charles Messier discovered both of those on one evening apparently. And the one M71's an interesting one. They debated for a long time whether it was an open cluster or a globular cluster. You can see it's quite loose in nature compared to a lot of the other ones, but they've actually determined now that it is a globular orbiting the Milky Way. And sort of feel sorry for M92. It's a beautiful cluster, probably almost as nice as M13, but it's also very close in the sky to M13. So I think it's quite often ignored because when people are in that area, M13 gets most of the attention. It doesn't get as much respect. So we'll move from our Milky Way galaxy and the globulars close to the Milky Way. We're going to go to the realm of the galaxies. So we'll go first to the Andromeda galaxy, and yeah, it's our closest sort of major galaxy, or next door neighbor. So it's 2.5 million light years away. We'll go back to our scales. So we were talking about the Earth's orbit being a dime, and our Milky Way would be about the diameter of the Earth. So at that scale, the Andromeda galaxy would be about half the Earth-Moon distance from us. So remember we said at that scale, the stars would be about a mile apart. We could hike to those stars, you know, and check some of them out, but it'd take probably a couple lifetimes to hike to the Andromeda galaxy, even at that scale. So yeah, records of the Andromeda galaxy go back as far as 1000 BC. It was, you know, it's probably the most remote naked eye object in the sky. It's very well studied because it gives us a chance to find out more about what our galaxy is probably like, because we know that our galaxy and the Andromeda galaxy are fairly similar, and since we can't see ours, it's sort of the easiest one to look at. As Simon mentioned, we've got M32 and M110 here, the two satellite galaxies around. It's a huge object in the sky. The spiral arms go out so far. It covers the area of about six full moons. So pretty amazing that way. The one interesting thing about the Andromeda galaxy is most of the objects in the universe are expanding. Everything's moving away from everything else. But the Andromeda galaxy is actually moving towards the Milky Way. So they're sort of on a collision course. And believe it or not, every second it gets 100 kilometers closer to the Milky Way galaxy. So you may be alarmed and think, oh no, we're in trouble, you know, but the distances again are so huge that it's probably, there won't be a collision for about 2.5 billion years. So yeah, we have no reason to be concerned. So just to look at some other galaxies here, M33, the Triangulum galaxy, it's a little smaller than the Milky Way and the Andromeda. It's a little farther away than Andromeda, but it's one of our local group of galaxies, very close, only just a little farther away than Andromeda. M101, you can see this loose structure about 10 times farther away than Andromeda and M33. But I believe it, Lord Ross, he was another famous astronomer. This is in the 1800s. I believe this was the first galaxy where they were able to resolve it enough to see the spiral structure. They called them spiral nebulae, and they didn't really know. It was Hubble in 1920. They didn't realize really what these spiral nebulae were, that they were actually other galaxies. But he was Lord Ross, and I think it was 1850. He was able to determine that it was actually a spiral structure. One really nice galaxy. I don't know how Messier missed this one. Maybe because it's in the southern sky more. It's a little harder to observe would have been from his latitudes. But the Sculptor galaxy, it's called. Herschel actually discovered this one also. It's a very bright, large galaxy. The Whirlpool galaxy, just a beautiful showpiece object. One of the brightest galaxies and one of the nicest ones to image. The Sunflower galaxy, or M63, it's got that really different pattern. The spiral arms supposed to resemble a sunflower. And M65, we can see this dark lane sort of crossing it here. They're all different in their own way. And these, you know, a lot of these galaxies are getting out into the, you know, tens of millions of light years away. This is the M82. It's also called the Cigar galaxy. It's sort of an irregular galaxy. They think it may have some spiral structure to it. M102 is interesting here. It just has a very thin dust lane you can see crossing the center of it there. The sombrero here looks like the Mexican hat. These are a couple of examples of the barred spirals, M109 and NGC 2903, and you can see sort of this bar structure in the center of the galaxy there. And there is pretty good evidence now to think that our Milky Way may have more of a barred nucleus also. NGC 891 that we looked at earlier. These are the Siamese twin galaxies, 80 some million light years away with the supernova there. This is an interesting one here, NGC 4762. It's got this elongated, really bright nucleus here. We're seeing it edge on. Not too sure, 53 million light years away for that one. Yeah, this is another nice edge on spiral here. You can just see the central bulge and the dark lane crossing it there. I didn't realize till after I imaged this one, 5985 here, it's actually 170 million light years away. So that's a very distant galaxy to get that sort of detail. This one's known as the fireworks galaxy. It's NGC 6946. The reason for the nickname is since observations have been made, it holds the record for 10 supernovas to have been discovered in the galaxy, more than any other one. So it's undergoing a lot of activity. So another good example of a barred spiral here. And this is an example. This is M49. It's an elliptical galaxy. There's the two main types of galaxies in the universe, ellipticals and spirals. And I apologize, I don't have many images of ellipticals, mainly because they're not nearly as interesting. Most of them look like a variation of this, just different sizes, but they're just spherical galaxies. Some of them are very huge though. There's giant ellipticals that can have up to 1 billion stars. They estimate our Milky Way probably has maybe, the estimates vary widely. They say, you know, anywhere from 100 to 400 billion stars, but this one, I believe, they think has about 6,000 globular clusters orbiting around it. So, yeah, pretty interesting. But you can't help to think when you're looking at these and millions of light years away, and you think of a sun and one of these galaxies might have planets around it, maybe some form of life. You know, a photon leaves one of those stars, leaves the galaxy, takes millions of years to cross all that intergalactic space, you know, enters our galaxy, enters our solar system through the Earth's atmosphere. That photon travels into your telescope, hits the sensor of your camera or the back of your eye, and it's just amazing, you know, to think that it's taken that many million years to travel through space. So one more image here, and I want to leave you with, and this is the only image in this presentation that I didn't take myself, but this is called the Hubble Deep Field. And what they did, they took the Hubble telescope and they focused on a very small part of the sky. Actually, this part of the sky they focused on would be about the same as a width of a grain of salt held at your arm's length. So very, very tiny. And they basically exposed for about 100 hours. And what did they see when they looked at what they had got? Just endless galaxies. Who knows how many galaxies are in this picture? So it's amazing. The universe is just galaxies as far as you can see. We'll do one more scale. Say if you could hold the Milky Way galaxy in the palm of your hand, this delicate galaxy in the palm of your hand, the Andromeda galaxy would now be about 7 feet away, be a little bit larger. And when you looked in every direction in the distance, all you would see would be galaxies. You'd see giant basketballs, giant ellipticals, you'd see ping pong balls, you'd see little peas, you'd see motes of dust, all different size ellipticals and dwarf ellipticals. You'd see spiral galaxies of all different shapes and sizes. But you could spend several lifetimes just walking around to see them all. I mean, just as far as you could see in any direction, there'd be galaxies everywhere. So that's what makes this hobby interesting for me, is just those questions on how big is it, where did everything come from, and it's just really challenges the mind to try to fathom it all. But I appreciate your attention tonight, and thank you. That's all.